So first of all, we're going to see how to enter and analyze your boxmaze data. So this is the first experiment, and in this sample data set which you can analyze, there are 36 mice, and they belong to either the group with no markings on its tail, or I should say the 0 marking on its tail, the 1 mark on its tail, or the 2 marks on its tail. And each of these mice was assessed for its rearing, crossing, dipping, and circling. And so you can see that each mouse has one line of data, and that, for example, the rearings are all arranged in a column. So this is how you need to enter your data for sigma plot. And now basically you have four different outcome measures. You have rearing, crossing, dipping, and circling, and you're going to need to run a separate analysis for each of these. And what you have here is one factor group that might predict differences in rearing. So you might, for example, expect the animals injected with amphetamine to rear more. So the factor that predicts rearing is group, and group has 3 levels, either 0 bars, 1 bar, or 2 bars. So this is a one factor analysis that has 3 levels, and in this case we're just going to analyze rearing, and then we'll run a separate analysis for crossing, a separate analysis for dipping, and a separate analysis for circling. So if you have one factor, then you can run a one-way ANOVA. So if you click up here, you select one-way ANOVA. Be careful not to select by accident the one-way repeated measures ANOVA. What you want is above it is the one-way ANOVA there, and then you click run. So now this window will pop up and it might say raw, but what you want to do is select indexed. So raw is if you just have columns of data. In this case what we have is indexed data, so all your rearings are in one column, and it's the group column that indexes them, so it tells the computer which animals had 0 marks, 1 mark, or 2 marks on its tail. So you select indexed and then next, and you select the column that has your group factor or predictor in it, and then we're going to analyze rearing first of all. So now you just want to make sure you have group in the group here and rearing there. Now you click finish. So this little window pops up and it tells you that the treatments are significantly different, and the p-value for that is 0.011, which is less than 0.05, so it's significant. And what this says is that the 3 groups of animals exhibited different mean levels of rearing, and that difference was significant, but it doesn't tell you whether, for example, the amphetamine group was higher than the saline groups, and so on. So what you have to do is a little more work, and this is called the post hoc test. There are various multiple comparison options for the post hoc test, but sigma plot is recommending the Holm-Sidak test, and I recommend you just follow its recommendation. So let's just click, you want to make sure that this is ticked. We're going to do all pairwise and click finish. And this is your analysis table, so it pops up here on this tab. So there was your data, and here's your report. So you ran a one-way analysis of variance, analysing your rearings data. We'll come back to the normality test and the equal variance test later. There's some summary data here with your group means and standard deviations, and then this little table here is called an ANOVA table, and the key line that you want to look at is where it says between groups, and this is your p-value of 0.011. so this is the main result of your ANOVA, your one-way analysis of variance. So there was a significant difference between the groups, and this sentence gives you that in plain English. It's the same thing. Okay, now this part tells you about the multiple comparisons. So this tells you which group was different from which group, and it uses the Holm-Sidak method. And if you want to learn more about that, you can consult a stats textbook. But this is the recommended one by sigma plot. And so you can see here that group 1 differed from group 0 significantly. That's its p-value, and this is just saying that yes, it's less than 0.05. Group 2 versus group 0 was significantly different, but group 1 versus group 2 was not significantly different. So this is the complete analysis of your rearing data. Now, as I mentioned, you have to conduct separate analyses for crossing and dipping and circling. And just to give you one more example, let's analyze the circling data. So we go back up to one-way ANOVA and we click run. The data is still in the indexed format, so we click next. The group column is here, and the circling column is here. So now we're just analyzing the circling data. So let's see, do the groups differ? Well, so sigma plot's come up with a warning message. It's saying that your data don't appear to be normal. So the normality test is failed, and this failure is highly significant, so it's telling you about it. but it's suggesting an alternative test. Do you want to run a one-way ANOVA on ranks? And this is also called the Kruskal Wallis test. And again, I recommend that you follow Sigmaplot's recommendations here. So let's run this alternative test, which is a non-parametric test. And now it says the treatments are significantly different. So by running the one-way analysis of variance on ranks, the Kruskal Wallis test, it tells you the groups are significantly different. Now in this case, it's suggesting that you use a Tukey test to see where the differences lie. Make sure that's ticked and click finish. And here's your, so you tried to run a one-way ANOVA on the circling data, but the normality test failed. So instead, ANOVA on ranks was begun. So this is the Kruskal Wallis one-way analysis of variance on ranks. Here's some summary data again, and this time you'll see medians and quartiles, and you can look those up in the textbook if you want to know more. And the p-value here is highly significant. So there is evidence from the Kruskal Wallis test to say that the groups differ. Okay, now where do the groups differ? So this is where you run your post-hocs, the Tukey tests, and group 2 versus group 0 was highly significantly different. Group 2 versus group 1 was highly significantly different, but group 1 versus group 0 was not. So again, this allows you to see where the differences lie. So your boxmaze data, your own actual data, you'll need to run 4 separate tests, and Sigmaplot will help you if the one-way analysis of variance should be replaced by the Kruskal Wallis test. And that's it.